Hello and welcome. This is topic number 6, addressing modes of 8086. Till now we have covered the architecture and the pin diagram of 8086. So why are we going to study addressing modes? Addressing modes, what does it signify and what does it tell you? So basically addressing modes help us to understand the types of operands and the way they are accessed while executing the instruction. So in this presentation we will study different addressing modes and we'll study these addressing modes with examples. So there are different types of addressing modes in 8086. There are 8 stated in the slide: immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, base plus index addressing mode, base relative plus index addressing mode. So firstly we will see the immediate addressing mode. So in this type of mode, immediate data is part of the instruction and it appears in the form of successive byte or bytes. So whatever data you are going to copy in this example given on the slide is given inside the instruction itself. So if you see the example move AX, 10AB. So in this, the data 10AB is there given in the instruction and which will be copied to AX register. So what will happen after the execution? The value 10AB will be copied to AX register. Okay, next is direct addressing mode. So in this mode of addressing mode, a 16-bit memory address is directly specified in the instruction as a part of it. So you want to copy from or to a memory location, and memory location has an address and that address is given along with the instructions. So as you see in this example, there is move AX, 5000. So this 5000 is the address in the memory where the data is taken from. Definitely 5000 is the offset and the segment address is given by the DS register, data segment register. So what is going to happen is that 5000, or you can say 5 lakh and 5 lakh 1, 5 lakh 2, the data from, so what you're going to say that 5000 is the address. 5000, 5001 and 5002 has different datas, but this is a 16-bit operation, AX, 5000. So 16-bit data will require two memory locations, that is 5000 and 5001, and the data from these two locations will come to AX, the AL and the AH, the lower byte and the higher byte. So that data from the location is copied to AX register. So that is direct addressing mode. In the next addressing mode, register addressing mode, in this type of addressing mode, the data is stored in the register and it can be a 8-bit or a 16-bit register. All the registers except IP may be used in this mode. So what is basically happening is that a data from a register is getting copied to another register. So there is source and there is destination, and the source data is stored in the destination register. So but both registers are given along with the instructions. So what is going to happen is that whatever the data is there in AX register is going to be overwritten with the BX register data, that is 10AB, as you have seen in the animation. Next is register indirect addressing mode. So in this mode, the memory location which contains data or operand is determined in an indirect way using an offset register. So you want to copy some data from a memory location, but the address you are not going to give it along with the instruction. The address you are keeping it in a different register. So in this example, as you see, move AX, BX, move AX, BX. So what is happening is that BX is holding a memory location address, and this address has few datas, that is 22 and 33. So 5000 has 22 and 5001 has 33. So this data is being pointed by the address given in BX register. So what will happen is that after the execution of this instruction, the data 2233 situated or located at 5000 and 5001 will be copied to AX register. Okay, so that is register indirect addressing mode. So let us recall or what we have studied till now. So we have posted a question, move 7000, CX. Which addressing mode does instruction above belong and why? So what we have to think is that where is the source and where is the data? So you can now pause for a minute, identify where the data is, where the address is, how the data is flowing from the address or the memory. So you can pause for a minute and just identify what is happening in this instruction. Take your journal and write your answer. So I hope you have written the answers to this question. So which addressing mode it is? Direct addressing mode, because the address where the data has to be copied is given along with the instruction. So what is going to happen in this instruction is that CX is your source register, 7000 is a memory location that is your destination. So what is going to happen is that the data from CX register is going to get copied to 7000 memory location and 7001. So what is going to happen is that data is getting copied to the memory. So that is the answer for the question. Okay, we move on to the next addressing mode, indexed addressing mode. So in this addressing mode, offset of the operand is stored in one of the index registers. DS is the default segment for index register SI and TI. Okay, next is indexed addressing mode. In this addressing mode, offset of the operand is stored in one of the index registers. DS is a default segment for index registers SI and DI. In the last addressing mode, we saw that the offset was given inside a register. And in this addressing mode, the offset is given inside an index register, that is SI or DI. So as you see in the example, move AX comma SI. So SI is pointing at a memory location and SI is a index register. And what will happen is that from that memory location, data will get copied to AX register. So if you see the animation, so from 5000 and 5001, the data has been copied to AX register. Next is register relative addressing mode. So in this mode, the data is available at an effective address formed by adding an 8-bit or a 16-bit displacement with the content of any one of the registers BX, BP, SI and DI in the default either DS or ES segment. So if you see the example in the instruction, move AX comma 50 hex. So 50 hex is pointing at a memory location inside the segment register. So DS and ES are the segment registers, and inside the memory there is a location, and location can be found out with the help of the offset, which is also given inside the instruction. So 50 hex is the offset and it is added with 5000 hex, which is pointed by the offset register BX, and the resultant value will be 5050. This is the memory location inside the data segment or the extra segment, and the memory location is being pointed by the resultant address 5050 hex, and data from that location will be copied to AX register. Okay, we see the next addressing mode, base plus index addressing mode. So in this mode, the effective address is found by adding content of a base register, any one of BX or BP, to the content of an index register SI or DI. The default segment register is ES or DS. Okay. So what is going to happen is that the offset address is going to be created with the help of BX plus SI. So if BX has 1000 and SI has 3000, the SI has 2000. If BX has 1000 and SI has 2000, the values of the offsets will be added and the resultant address will be 3000 hex. And this 3000 hex is the resultant offset index address, which will be inside the data segment or the extra segment. And that location will give us a 16-bit data which will be copied to AX register. Okay, I hope you're getting it. So last is base relative plus index addressing mode. So in this addressing mode, we have a combination of both the previous modes. So what is happening is that we have the BX register, we have the index register SI, and we have the offset. All these values will be added together to get us the effective address. So if you think about the example given in the slide, that is AX will have the data from the memory location 50 plus 1000 plus 2000, that is 3050, and the data will be copied to AX register. Okay, so that is base relative index addressing mode. So summary, So we have studied different addressing modes, and we have understood, how different addressing modes have different data in different locations. So sometimes you will have the address, sometimes you will have the data, sometimes we'll have the register which has the data, sometimes we have the register we have which points to an address. So these are all the different addressing modes of 8086. So thank you so much.